String-time crystals, Part 3. String-time crystals and Bose-Einstein condensates for therapeutic application in quantum feedback. September 2024, by Dr. Hovdank Tadeusz. String-time crystals and Bose-Einstein condensates as a new state of matter involves three parts: holistic string-time crystals theory, string-time Bose-Einstein condensates matter, and string-time crystals and Bose-Einstein condensate for therapeutic application in quantum feedback. Quantum states in biological systems. Biological molecules, cells, and tissues can exhibit quantum properties like superposition, entanglement, and coherence. These properties create a quantum information field that reflects the health status of a biological system. Chirality in DNA. Chirality refers to the geometric property where a structure is not superimposable on its mirror image. In the context of DNA, helical structure, DNA molecules are inherently chiral due to their double helical structure. The right-handed double helix is the most common form found in nature bDNA. In enantiomers, the two strands of DNA twist around each other in a specific right-handed fashion, meaning their spatial arrangement cannot be mirrored to look the same. Chirality coherence. Chirality synchronization and dynamic mirror symmetry breaking involves a balance between internal and external influences, where the alignment of molecular and structural chirality within the system facilitated by connectivity and cooperativity is influenced by interactions with chiral and achiral surfaces. Understanding these dynamics is crucial for designing V with desired chiral properties. Polarity in DNA. Polarity refers to the orientation of a structure that has distinct ends with different properties. In the case of DNA, this concept is seen in the directionality of its strands. Each DNA strand has a 5' end and a 3' end, and this polarity is absolutely crucial for processes like DNA replication and transcription. Additionally, the two strands of DNA are antiparallel, meaning they run in opposite directions. One strand runs 5' to 3', while the other runs 3' to 5'. This complementary arrangement is fundamental to the way DNA functions and replicates. Chirality and polarity in liquid crystals. As an analogy to DNA, the exploration of liquid crystals has taken a significant turn with recent findings published in the June 2024 issue of Science, where researchers have documented the spontaneous emergence of both polar and chiral properties in ferroelectric nematic phases. This groundbreaking research by Polish scientists showcases a unique phase of liquid crystals where achiral molecules organize into chiral structures without external chiral influences, driven purely by intrinsic electric dipole interactions. Quantum interference between synapses. Quantum interference is essential in quantum computation because it allows multiple computations to be performed simultaneously. In orchestra OR, the quantum interference among different states of tubulin could enable complex, parallel processing of information at a quantum level. The dynamic instability and ability of microtubules to polymerize and depolymerize could be linked to quantum processes that affect synaptic function and neuronal signaling. Microtubules. Repeating, highly ordered arrangement in microtubules is crucial for maintaining stability and regularity, which is essential for supporting coherent quantum states and processes. Microtubules have inherent polarity, allowing them to exhibit dynamic instability, which could facilitate rapid adjustments in the quantum state, potentially important for quantum computation and maintaining coherence. These periodic dynamics and oscillations in growth and shrinkage phases are conceptually similar to the behavior of time crystals. Synaptic signaling and microtubules. Synaptic signaling is integral to neuronal communication and involves the release and reception of neurotransmitters at synapses. According to the orchestrated objective reduction theory, microtubules within neurons could influence synaptic activity by affecting neurotransmitter release and reception. The dynamic instability and ability of microtubules to polymerize and depolymerize could be linked to quantum processes that affect synaptic function and neuronal signaling. Microtubule subharmonic oscillations. Microtubule excitation band in the megahertz range 0.1 to 100 MHz when externally applied frequencies are triggered from 0.1 to 178 GHz at the 100 to 200 MHz gap. Experimental setup. An experimental setup when quantum interference measurement is used to find microtubules excited oscillations frequencies. Environment-induced time crystals. Environment-induced time crystals (EITCs) provide a conceptual framework for understanding how structured, rhythmic interactions between an individual and their environment can catalyze significant positive changes in both perception and physiological states. Rhythmic interactions enhance cognitive processes, neuroplasticity promotes learning and emotional balance, biological rhythms govern bodily functions, rhythmic stimuli support homeostasis and healing, mind-body connection fosters holistic health. Therapeutic applications leverage rhythmic stimuli, behavioral modulation aligns with optimal health, resetting bodily rhythms improves chronic conditions. Spectroscopy in time crystals. Spectroscopy techniques, including two-dimensional electronic spectroscopy 2DES and spin noise spectroscopy, are crucial for studying time crystals by revealing their unique properties like subharmonic responses, coherence, and symmetry-breaking behavior. 2DES provides detailed insights into temporal correlations and interactions, while spin noise spectroscopy measures spontaneous spin fluctuations to detect natural spin dynamics and stability in time crystalline phases. These methods, along with optical, microwave, neutron scattering, and NMR spectroscopy, help explore the dynamic properties and potential applications of time crystals. Nuclear magnetic resonance spectroscopy. NMR can be used to observe quantum coherence through spin-spin coupling and relaxation times. It can also detect entanglement by measuring correlations between nuclear spins. Techniques like quantum state tomography can be employed to reconstruct the quantum state and verify entanglement. SQUID, superconducting quantum interference device. SQUIDs are used in various applications, including biomagnetism, e.g. magnetoencephalography for brain activity mapping, geophysics detecting subtle magnetic anomalies, fundamental physics research measuring minute magnetic properties, and quantum computing qubit state measurement. Optically pumped magnetometers. Optically pumped magnetometers (OPMs) are highly sensitive devices used to measure very small magnetic fields, superior to MEG with a SQUID sensor. Their ability to detect extremely small magnetic fields allows researchers to measure subtle brain signals that might be influenced by quantum states, providing insights into neural activity at a very fine scale and the possibility of detecting quantum coherence or other quantum phenomena in the brain. String time crystals as a framework for brain and quantum brain network model showcased with the following diagram. String time crystals provide a framework for brain time crystals model, where oscillatory mode and string find their representation on the synaptic level via the microtubuli present in the synapses, further represented by brain's polytime crystal model and towards the quantum brain network with its dynamic tunneling resonance processes. Polytime crystals, brain time crystal. Polytime crystals, which is a model for the brain in holy string time crystals theory, is composed of multiple atomic or subatomic constituents. They are proposed to interact with the quantum information field due to their multidimensional periodicity. Polytime crystals contribute to brain functionality and neural processes by facilitating higher dimensional information exchange, thereby enhancing cognitive functions and perceptual abilities. For example, polytime crystals in neuronal microtubules might project holographic patterns that extend beyond their physical origin, suggesting a novel mechanism for quantum-based neuronal communication. Quantum diagnostics and string theory in physical therapy. Resonance-based therapy design. Concept: align electrostimulation frequencies with the healthy vibrational modes of biological systems, inspired by string theory. Mechanism: use frequencies that resonate with patient's natural quantum states to correct vibrational misalignments. Adaptive feedback and optimization. Continuous monitoring. Quantum sensors monitor vibrational states in real time during therapy. Adaptive feedback loops, adjust frequencies dynamically using AI and machine learning based on patient response. Machine learning algorithms, analyze session data to refine frequency selection and improve outcomes. Quantum diagnostic techniques. Quantum sensors and measurement. Advanced sensors detect and measure quantum states and properties of biological systems. Quantum tomography reconstructs quantum states from measurements to map out the body's quantum information field. Holographic health diagnostics. Based on the holographic principle, surface measurements e.g. skin conductance reflect the entire system's health. Allows for non-invasive diagnosis of internal conditions by analyzing surface data. Practical implementation of quantum therapy. Initial assessment: measure quantum states and identify deviations from healthy vibrational modes. Use string theory models to determine appropriate electrostimulation frequencies. Personalized therapy: implement tailored electrostimulation protocols based on patient's unique quantum information field. Adjust therapy in real time based on feedback from quantum state monitoring. Evaluation and optimization: reassess quantum states post-therapy to evaluate changes and refine future sessions. Continuously improve treatment effectiveness through data-driven adjustments. Electrostimulation and quantum neurofeedback work by monitoring the patient's quantum states in real time. Using this data, we apply targeted electrostimulation to bring their system back into alignment with healthy vibrational modes. At the same time, quantum neurofeedback helps the brain adjust to external stimuli, promoting balance and healing. We also use an AI-generated health model. This model is created by processing the patient's quantum data, and it serves as a template for the therapy. The model helps guide the electrostimulation and other treatments, ensuring they're specifically tailored to the patient's unique quantum state. MedBed for astronauts. In space travel, astronaut health is crucial, and technologies like the MedBed and holographic doctors demonstrate how quantum theories could enhance medical care. The MedBed provides immediate diagnostics and treatments, potentially using quantum principles to improve cellular health. Holographic doctors allow real-time consultations with Earth-based experts, using advanced quantum communication. These technologies show how quantum concepts can support astronaut health in space. The concept of homo quanticum centrism is based on quantum phenomena integrated with holographic theory. Quantum holographic human centrism emphasizes the observer perspective, in which the main focal points are the quantum holographic features of human cognition and consciousness. Quantum language model provides the possibilities of quantum computation or represents linguistic structures based on quantum theories, and delving into the idea that the synaptic quantum space reflects the human intellect. Biohology is an emerging interdisciplinary field that integrates biology with concepts from quantum mechanics, holography, and string theory. It seeks to understand biological systems through the lens of quantum phenomena, investigating how quantum principles like vibrational modes, quantum coherence, and time crystalline behavior might influence biological processes, such as cellular functions, biomolecular interactions, and biological rhythms. By applying quantum and holographic models to biology, biohology aims to uncover new dimensions of biological systems and potentially redefine our understanding of life at the quantum level. The work in Homo Quanticum Centrism Lab applies string theory and time crystals in biohological research. Quantum strings in biohology research focuses on exploring how string theory principles, such as vibrational modes of strings, might apply to biological systems, potentially revealing new quantum properties of biomolecules. Time crystals in biohology research investigates the presence of time crystalline behavior in biological systems, studying how repeating temporal patterns at the quantum level might influence biological rhythms and cellular functions. DAQ, which stands for Distributed Ledger Technology, Artificial Intelligence, and Quantum Technologies. These three pillars work together to enhance astronauts' health monitoring and treatments during space missions. First, distributed ledger technology enables secure, real-time tracking of astronauts' health data and treatments. It ensures that all medical data is encrypted, tamper-proof, and readily accessible for ongoing analysis and decision-making. Next, we integrate artificial intelligence to drive diagnostics and optimize time crystal therapies. AI provides real-time feedback and uses adaptive algorithms to adjust treatments based on continuous monitoring, tailoring care to each astronaut's needs. Finally, quantum technologies, with a focus on string theory, align quantum vibrations with astronauts' biological systems. This supports cellular and mental health, introducing quantum-based neurofeedback and enhancing oscillatory coherence to maintain overall well-being during long-duration space missions. Together, these technologies under the DAQ umbrella represent a comprehensive approach to ensuring astronaut health and safety in space. Medical quantum physics and string theory offer groundbreaking advancements in healthcare, particularly through the integration of quantum technologies and theoretical physics into medical practice. Let us start with quantum imaging and diagnostics. By leveraging principles like quantum superposition, entanglement, and string theory, we can achieve higher resolution, non-invasive imaging. This allows us to capture biological processes at the subatomic level, giving us unprecedented insights into the body's inner workings. Next is quantum sensing in healthcare. Ultrasensitive quantum sensors can detect subtle biological signals, such as brain waves or cardiac fields. With the help of string theory-inspired models, we may be able to explain deeper structures of biological fields and their interactions, advancing our understanding of the body's electromagnetic environment. Moving to quantum computing and medicine, quantum computing provides fast, precise simulations crucial for drug discovery, genomics, and personalized medicine. String theory's multidimensional framework might offer new ways of modeling biological systems, enabling better predictions and medical outcomes. Finally, quantum biology and string theory examines quantum effects in biological processes, such as DNA behavior and protein folding. String theory's concept of vibrating strings can help us understand complex biological interactions and cellular mechanisms, leading to new breakthroughs in how we approach human health and disease. Together, quantum physics and string theory have the potential to revolutionize the way we diagnose, treat, and understand biological systems. String time crystals meditation. Example: deviation from random's outcome during special event. Average deviation from mean in a series of events, here GEHP events. There is an apparent connection between the behavior observed in Global Consciousness Project GCP generators and the concept of time crystals, particularly in the context of time wave network events. Human consciousness and global events might influence fundamental probabilistic processes in a regular, structured way, suggesting a deeper connection between consciousness, time, and physical reality. The universe could be a neural network. A network similar in structure to the human brain, where universe operates as an interconnected computational system, mirroring the structure and function of the human brain. This concept aligns with theories like bosonic string theory, time crystals, and biohology, where complex quantum behaviors, symmetries, and patterns, such as those seen in neural networks, could underlie fundamental processes of reality, including biological and cosmic phenomena. It implies that just as neural networks process information through interconnected nodes, the universe might function through a web of quantum states and interactions, creating a holographic, interconnected fabric of existence. Holistic string time crystals theory. The journey to fully comprehend and harness the potential of time crystals is just beginning. This interdisciplinary approach, which merges classical physics with quantum realities within a holistic framework, paves the way for a new era of scientific discovery, where the boundaries between the observer and the observed, the classical and the quantum, are continually redefined. Brain-to-brain interface is an emerging field that explores the direct communication and interaction between two or more brains through neurotechnology and neural signals. It merges physics and neuroscience and suggests a fascinating question: could the brain function like a biological time crystal? This idea explores whether rhythmic brain activities and autonomous biological functions could be analogous to time crystalline behavior. This interdisciplinary approach marks a new dialogue, connecting the abstract physics of non-equilibrium structures with the tangible realities of biological processes. Thank you all for your time and interest.